In this orthokeratology case, we have a patient who's got some corneal cylinder. It looks mostly oblique in both eyes, and if we look at the patient's refraction, it's mostly cylindrical, closer to against the rule in the right eye, but close to a 45-degree axis in the left eye. So this will be kind of a challenging case. Hopefully your patient understands. And anytime we have higher cyl relative to sphere, makes the case a little bit more challenging. With the rule, cylinder is easier to mold, and I would say oblique is going to be the most difficult. Add on top of that, we get a little bit of conflict between what the patient's getting in the refraction versus what's on the cornea, suggesting there's a fair amount of internal astigmatism that we would need to take into account. But that said, what I would do in this case is use an oval optic zone so that we can separate up the treatment. Since we really don't need very much spherical flattening, we only need the flattening in this one meridian in the right eye, and then this one in the left. So the way we're going to design this oval is we want the shorter side of the oval to be in this meridian, as well as the higher topo demand. So I'm going to go up to here, 50% mode, and reduce this by 0.6 millimeters. This way, in this meridian, the back edge of the reverse curve here at the blue control point will match up with the optic zone in the opposite meridian, or the meridian 90 degrees away. Now the power in this meridian is only a quarter, so we really don't need any molding here. I'm going to decrease our topo demand a full diopter so that it's just pretty close to 0. And we'll do the same thing on the other side. In this meridian where we want to have more of the molding, we'll need a differential. And what I normally do is calculate about 1.5 times the amount of cylinder we want to correct. So we'll aim for a differential of between 2.5 to 2 3/4 diopters. So if we're about a quarter here, then here we want to be between 3 and 3 1/4. So I'm going to increase our topo demand here. And same thing here. So if we look at the back surface of the lens, we can see that we've got almost no molding in this direction, and all our molding going this way, where we have the steepening in the cornea. And we have approximately a 3 diopter differential between these two perpendicular meridians. I would do the same thing for the left eye. The only difference is everything will be 90 degrees away, so that we get most of our molding in this meridian, And then this one that goes from inferonasal to superiotemporal is going to be close to a zero power or zero, very, very low topo demand. So this combination of oblique optics and internal astigmatism, sometimes we still end up with a case where the vision isn't very good, but this is how I would go about, at least for the next step. We can still certainly learn from the case and hopefully contribute to this patient's quality of life through ortho-K as well. So those are my thoughts. Best of luck with your patient.